This is kind of amazing because all these people are on these like seats in the back, so it looks like a wall of human like coming at me. Just terrifying. Anyway, we're going to talk about time because if you don't realize this, it is time to talk about time. If you didn't like that pun, you're in trouble. I have so many puns this talk. So, step one, time is hard. For example, you may have thought that this conference started at 10 in the morning. Turns out, here we are later. But yeah, time is really hard. Time is hard regardless of what language you pick, what hip, cool framework and stuff that you're really excited about. Pretty much everybody uses timestamps, date stamps, some sort of time-related thing in their code, and it should really terrify you. And a lot of times you'll see this online, like, oh, just use UTC. It's going to fix all your problems and stuff. And we like to say this a lot. And we say lots of blog posts and Stack Overflows and lots of other things about just use UTC and everything will be fixed. Well, I'm here to tell you that is absolutely, mostly true, but there's a lot more to it than just using UTC. So I'm Zach Holman, Holman on all the social media things. As you can see in this photo, I represent programming time, and my cat represents how terrified you should be of me. I love this photo because Stripe actually shot this photo. Like, they paid money for this photo to happen, which I'm really happy about. Yeah, once upon a time I worked at GitHub. I worked there for like 5 years, and starting like 2010. And for a long time we had a running joke between one of my coworkers. He had built a lot of like scheduling and calendar stuff in the past, and he just kept telling me, Zach, whatever you do, never build a calendar. And I was like, yeah, I'm not that stupid, like that's ridiculous. So yeah, I'm the co-founder of During, it's a calendar. Not very good at following directions. But yeah, we're building a calendar, so we run into all of the really terrible edge cases involved with scheduling and time and recurring events and all this sort of stuff. So we get like everything that's terrible. But everybody runs into some of these problems many times in their career, like in different aspects of like events or scheduling or just straight up timestamps and stuff. And I think it's important to start figuring out like, oh, how do we make all of our time code more resilient and better for our users and stuff. So I've been thinking about this a lot for like a year or two, and I've been making a lot of notes about what I wanted to give in a talk, and I wanted to share with you some of the things that I've learned. So, quick talk today, a couple different sections. First is, what is time? We're going to get really deep and philosophical. Then we're going to talk about why time is so hard. And then finally, like code and time and how to make them work together and not be terrible and stuff. So the first thing is, what is time? It's a question as old as time. Apparently, this is a good question to ask because like physicists are now asking, like, does time actually even exist? Is this like an actual thing, or like, is it irrelevant to quantum mechanics and stuff like this? I don't really understand any of that sort of stuff. You probably won't have to deal with quantum mechanics in your Rails apps, I'm hoping. If you do, there's probably a gem for it anyway, so it's fine. So, we exist. I think that's all that matters. We can go from there. I want to first start out with like a brief timeline of time, and kind of give some background on all this sort of stuff. So about 4000 BC, we started getting astronomical clocks. We started having a concept of like, what is a day? That's good and helpful to know. 1500 BC, we started having sundial subdivisions. Before this, we kind of just stepped outside and were like, yeah, it's daylight, or no, no daylight. Now we can start figuring out like, what proportion to the day are we? Like, that's pretty helpful to know. It wasn't until like the 14th century where we started having fixed length hours. Previously, like the hour length changed seasonally depending on the growing season. Most of everything that's really weird about time stems from farmers, because farmers are really important and they need to figure out how to grow stuff. Like you couldn't just like walk down the street to McDonald's and like, get a burger, I guess. You had to grow your own food like farmers, which is weird. 16th century, we started having minutes. Nobody really cared at that point. We didn't really have the technology to build minute accuracy and stuff, but now like, our ancestors' bosses started like making all of our ancestors go to work on time and stuff, so you need to know like, what minute they have to get to work and everything. 17th century, we started having seconds. There's a really fascinating story about the inventor, the first person who made a clock with seconds. Like his first prototype was garbage, but he got it right the second time. You wouldn't believe how much I laugh making this talk sometimes. I do this talk for me, not for you. 1883, USA and a bunch of other countries started like standardizing what the concept of time is, because it's the most bourgeois scene of possibility. In the 19th century, a bunch of like rich people who owned railroads went to a hotel and were like, we need to standardize hotel railroad times and stuff. So we started seeing like time zones and cities being synchronized back and forth, and like that started being really interesting. They used the newfangled telegraph to synchronize time between distances, which is kind of cool. Then in 1967, we started getting an actual atomic standard, which is really exciting. So if you have a lot of like cesium atoms in your backyard, go out and grab one and then count out 9,192,631,770 energy transitions of the cesium atom, and that is 1 second. So that's pretty cool. Atomic clocks are pretty exciting stuff. They only lose about 1 second every 1.4 million years, which is definitely the reason why I'm late to all your meetings, because my atomic clock is just so slow. And like now we're getting some really interesting stuff. We have like optical clocks, which are like 100,000 times more accurate. So like if you have one of these optical clocks that they're working on now, and we started at the beginning of the Big Bang like 14 billion years ago, it would have lost about 4 seconds of accuracy to this point, which is kind of amazing. Like humans are, not terrible sometimes. And then in 2018, you fuck up your time zone bug. This is the standard process of all programmers with time. Everything I just mentioned revolves around one simple question. What time is it? Cool. What time is it? What are we meeting? What are we going to do this at? Awesome. Simple question. But there's like an implicit part of this question that we never asked for a while. It was always, what time is it here? Because all we could really be was here. I could walk down the street by the end of the day or something, and I guess that's over there, but it's basically the same time and stuff. At some certain point, we started asking the question, what time is it over there? And that question ruined everything. Because you have to start figuring out, like, well, time zones, and the rotation of the Earth, and the Coriolis effect, and all this sort of dumb stuff. And it really made everything terrible. This is one of my favorite kind of photos. It's the universal dial plate from 1854. And all these little dials are like different cities and what time they were in that specific city compared to everything else. So if you thought like programming now is tricky, try programming JavaScript in like 1850. You would have had a hard time. So if you start figuring out like, all right, we're gonna make time a thing. And you start figuring out like, oh, how many time zones should we have? We have 24 hours in a day, you have 24 time zones. You probably pick up 1 hour per time zone and stuff. Obviously not correct. We have like 39 last time I checked. And this is like the first step of like why everything is terrible. You start figuring out like, oh yeah, time zones get added gradually, haphazardly, depending on politics, economics, just because you want to screw over your neighbor or something like that. Like time zone gets really weird, and like this time zone data gets updated dozens of times a year. If you ever use the Olsen database, it's like a standardized database that has all of these rules of who's moving what daylight savings time and time zones and stuff. It's really tricky to try and figure this out. So there's a lot of things like around that's like important to keep in mind. Like time zones, for example, are not just 1 hour increments. There's a lot of time zones that are 30 minutes off, or 45 minutes off. The 45 minutes off are terrible people, and they should never have done that. But there's a lot of different complications around what time is over there. And all this stems from like, we're trying to take a political problem, trying to figure out like governance models and stuff, and map them onto a very irregular system, like a second. The billion oscillations of a cesium atom and stuff like that. Like it makes it hard. Time is hard. And this is where all the problems stem from. So specifically though, why is time really hard? I'm happy to say like humans have been really, really bad at time for a long time. Like it's not just you. As a civilization, we're pretty shit at like managing all this sort of stuff. It's kind of like if you build like a really nice nice house. It's got all the cool stuff in there that you really want, and then you build a like really terrible foundation. Like this is not going to be really super good for you. I'll give you a quick example. Does everybody remember December 30th, 2011? One voice was like, yes. Everybody else, I'm just going to assume you're all Samoan. Because Samoa went from December 29th, 2011 to December 31st, 2011. This is interesting. So, Samoa used to be east of the international date line. That's the separation between like days on the planet. And this is cool. They decided one day, they looked up and they were like, wow, all of our trading partners are like China, New Zealand, Australia, Japan, and you know, we're busy working on a Friday and they've already fucked off for the weekend. Like, this is really weird, you know? We should really be on the same day as like our trading partners and stuff. It was a good idea. The other important thing to kind of keep note of is that American Samoa is about 100 kilometers away. Not too far, and they both have Samoa in the name, so that's, you know, something. So let me break this down for you. You have the Samoa time zone, which is Samoa and American Samoa, which is two different countries. It's actually one country in an unincorporated territory, because one of them is an unincorporated territory in the US. Samoa says, all right, we're going to get out of this time zone, we're going to go on the West Samoa time zone. Samoa's over there now, this is UTC minus 11, West Samoa is UTC plus 12. So this is 24 hours ahead of American Samoa, even though they're only 100 kilometers across from each other. Which isn't totally true because they're actually 25 hours ahead of American Samoa, because Samoa time zone doesn't observe daylight savings time. West Samoa also doesn't observe daylight savings time, except it did starting in 2009, which is also not true because they pushed it back a year because of the Samoa earthquake and tsunami. It's like, oh wow, this is really weird. The astute among you are like, I've heard this before, probably because you knew about Samoan time in July 4th, 1892, where the opposite happened, where they looked up and they're like, our trading partner is the United States, like we should go over to their side of thing. So they had July 4th, 1892 twice, which is awesome because it's the Independence Day, so they could do like fireworks twice in a row for 48 hours. It was really exciting. And now all of this is very similar to Tokelau, which is very similar and nearby. It's a territory of New Zealand, and they're looking at what Samoa's doing, they're like, I gotta get in on this too. So they moved to West Samoa as well, also on December 30th, 2011. So, BBC sent a journalist over there and interviewed a bunch of people while this is all happening. They said, you can hear the sound of a lot of vehicles going around town, going around the town center clock and tooting their horns, people screaming. We have once again achieved another milestone in the history of Samoa. I don't know who they interviewed, but whoever said this doesn't have to fucking deal with all the time zone problems stemming from this. Time is hard. All this stuff is really hard. Another quick example. 1918, Russia switches to the Gregorian calendar. Previously, in 1908, Russia was on the Julian, England was on the Gregorian. This is really important because the 1908 Olympics were in London. Now, the number of days late the Russian Olympic shooting team arrived in London for the Olympics was 12, which is really weird. So they missed their entire Olympic event because they were just on the wrong calendar. This is a bummer, but I'd feel more bad if Russia didn't do this before, because the number of days late the Russians showed up for the Massacre of Auschwitz in 1805 is similar, because their Austrian allies were waiting for them to be reinforced, and they sent them a certain day, but they're on a different calendar. It was all just really confusing stuff. Yeah, they lost anyway. All of this stuff is really hard. Time is really hard. I have a huge long list of examples like these, but I just don't have the time. Time is hard. So let's get to the main event, code and time. We're gonna actually have to code around some of this stuff at some point, which is disparaging, but it's exciting. It's only exciting to people like me who really loves this stuff. So when I was writing this talk, I was really listening to the words of one of my favorite modern day philosophers, Nasty Nas. And he said, you got CD-ROM, everything operates by computers, and what happens when the circuit breaks? Y2K, the big scare. Scientists say we ain't prepared. Now I'm not really sure what this means other than if Nas is concerned about this, like we should really be concerned about time and stuff too. So keep that in mind as I go into this. A bunch of little bits that I want to talk about here. First one is about storing time. Like how do you store this stuff on your systems? Use UTC. It's like the whole talk. This is good advice. There's a reason why people keep saying this sort of stuff, UTC is good. Now, for those of you who don't know what UTC really is, it stands for Universal Coordinated Time. This deserves some explanation. Now in English, this would have been Coordinated Universal Time. In French, it would have been Temps Universel Cordon or something. I don't speak French. Something weird like that. So it would have been cut and tuck. And obviously the standards bodies were like, this is ridiculous. We should have one name for this, so they picked UTC. You know, from the start, when your time standard doesn't correctly map to an acronym, you know you have a problem. Or this is just a really good metaphor for working with time. Like none of this really makes any sense. But I guess it makes sense because it's a standard. So anyway, UTC has an offset of like 0. The important thing to note here is that UTC is not GMT, Greenwich Mean Time. They're sometimes the same, But even though GMT is UTC plus 0 as well, GMT is an actual time zone. Like people live in GMT, people don't live in UTC unless you're really, really strange. UTC is the actual standard that we use. The other thing about this, GMT, some users of GMT use daylight savings time. UTC does not have daylight savings time. So it's important to know all that sort of stuff. Use UTC. First real question I wanted to kind of ask is, like, do you actually need to store time? I think that's the very first thing that you have to, the number of times when I've sat down to code something and I blew like an hour or two on it, and I'm just like, oh God, I really didn't need to do any of this sort of stuff. Worthwhile to ask that question here too. As programmers, we kind of want the highest fidelity format, right? Like, I need absolute nanoseconds of when this event happened because, maybe I'll need that in the future. And it's like, no, not always. And there's some good examples where you may not need this, like birthdays, for example. You don't have to store the time, you can just store the date. It's kind of like a floating event type of thing. And that may be fine, you can just sidestep all these sort of problems later on. You just store like that as a date and stuff like that. So you might have something like, if you have like an events table of something happening, you might have like a starts at with a normal timestamp and stuff. And if you do actually have to need to store the actual time, like the two things that you may want to do is you store the actual timestamp, but then you also store the time zone of when the thing actually happened. And this is interesting to know that this is probably a string rather than just like a number offset of minutes or something like that. Because you store the offset of a string because you need to figure out retroactively. If it's really important to figure out, like, did this happen this hour or this hour? If you store the string of the actual time zone, you can go back in time and figure out, was this actually daylight savings time at this point? Did the country change daylight savings time later on? And if you store it just as like a number, you lose that fidelity of format and stuff. You don't know if it was daylight savings time at the time. So you really want to store it something like the IANA qualifier and say like, Australia Adelaide, this is the time zone. Cool. Next little bit, once you have the time, how do you translate it to your users? I just realized how ridiculous this little sketch thing is. It's like, it's raining time to your computer. I love that. I'm really happy with myself sometimes. Step one, just be consistent in all of your API calls. Like, this is really all there is here. And by that, I mean, like, be really consistent, use ISO 8601. This is like a standard that was made in like 1988. Basically, it's a way of standardizing like what format a particular time string is, and it's used everywhere. In Ruby land, you'll do something like timeout.ISO 8601, and obviously everybody knows what happens there. You get an undefined method error because I guess there's a time class in Ruby, and then there's another time class in the Ruby standard library. Neat. Basically, you have to require time before you do this. If anyone actually understands really the reason behind this, go fuck yourself. I'm just kidding. That's really mean. It doesn't make any sense to me, but this is how you end up getting like a nice, this is like a nice ISO 8601 formatted string. And this is what you should be translating to your client, regardless of what language or API or whatever the case you're using. There's a couple reasons why this is such a bomb-ass standard. For one, you get like sorting for free. Anybody can write something where even like visually you can sort this and be like, oh yeah, I know when this happened and stuff. It's very neat and orderly. It also includes time zones. You don't get this from like if you're just storing like the Unix epoch or something. You get a nice time zone representation of like what the actual moment in time actually is. You get no locale problems. We'll get into this a little bit later. Basically, like the rule of thumb is just if you're ever going to have like an API or something where you're sending stuff to your client, just use ISO 8601. If you're a real nerd like me, you can also look at RFC 3339, which is basically like a subset of ISO 8601. This is a little bit newer, it's like 2002. Basically requires like timestamps. It's slightly more strict, but it's basically 8601. Most APIs that you're going to end up using, like I know GitHub uses 8601. It's great, it's awesome, and this is probably the most you'll ever want to learn about a standard of all time. Another little thing in Rails, we have the nice active support time zone classes and stuff, where you can do like a time.zone, and you get like a nice fancy like Pacific time, US and Canada. And it's really gentle because like Rails does stuff like all this time. And it's great, but it's this is a non-standard thing. So you shouldn't be like translating this to your clients. Your client itself shouldn't actually see this string. You should always persist or send like the actual qualifier that's standardizing stuff. So from that you can go into time.zone.tzinfo. It could do the whole tzinfo object, and then you can just do canonical identifier, and then I can see like the America Los Angeles rather than US Pacific, whatever. This is going to give you the most standard way of identifying a time, regardless of what language or crazy stuff you may be using. If you really want to go crazier on this, just install the TZ Info gem, and it gives you a whole pile of additional help with whatever you need to do. Next little thing is formatting time. I saw this tweet a little bit ago. British press corps is locked outside the White House because our birthdays were submitted in UK format and Secret Service doesn't get it. Apparently true. You know, insert your favorite American joke right now. And you can see this a lot, like this sort of locale problems and stuff. Like in 8601, we have a nice, 2008, 4-3, like we know what month and day that is. England, they may do one thing, the US may do another thing. I don't know what French does because I'm not French. But like the problem is, I don't know what's going to happen here. This is really crazy. So use user preferences where possible. Allow users to set their own personal preferences in terms of how they want to format the date, because people are going to come up with some really weird stuff that you may not be familiar with yourself. And it's strangely insulting if you see a date formatted for like America, if you're not American. I think. I don't know. I'm American, so I don't know. We ruin everything, I guess. In JavaScript land, you use like the international class and helpers and stuff. And it's a bunch of like datetime formatting specific to your browser locale, so you can kind of get a jump into formatting stuff without a lot of work to try and figure out, oh, where is this actual user located and stuff. And across like everything, like use time libraries as much as possible. There's so many edge cases that you don't want to have to deal with all that stuff yourself. If you're doing like really complicated time measurement or things like that, Moment.js is kind of the gold standard in JavaScript. It gives you a lot of like date addition, subtraction, whatever the case is, formatting and stuff like that. Date functions is kind of the new kid on the block. It's a lot better, I think, in a lot of ways, which is kind of interesting. Time elements is a GitHub project, which is really interesting because they basically help you figure out that browser locale stuff a lot better. And that's kind of another possibility if you want to look into how do I format this better, how do I do like a bunch of other browser-based locale stuff. And then the other thing I want to talk about this is like, once you kind of find an abstraction, like abstract it a little bit, because like everything, like there's going to be a new kid on the block that's like even cooler and hipper and stuff, and you don't really want to be tied directly to a particular library, if possible. Other thing I want to kind of mention here is accessibility. The accessibility of actually formatting a string on a page or whatever the case is. In your normal social graph website machine thing like this, you'll have something that looks kind of like this. A chunk of text and stuff. At the bottom, you might have like a relative thing like 2 minutes ago and stuff. Like, this is pretty normal. But I think there's a lot of problems here from like an accessibility from a general way of printing the page problem. For one, it would be nice to update that timestamp in real time. Like if you leave the page open for a long time, it should move to like 3 minutes ago or 2 weeks ago, or like however long the tab is open and stuff. So it's nice to have timers that update these every 60 seconds, so you kind of always have fresh data on the page. Two, like you get a lot of these were like about a year ago. Was it like 5 months ago or like 14 months ago? Like it's a big span. Like thanks, but that's not super helpful. One of the things that I've loved that GitHub has done for a decade now, I think, is use like the title attribute on every time that's ever printed on a page, and then you can see the actual full UTC. I think GitHub now formats it to your locale or something, but you can get a much better idea of like, oh yeah, when did this actual event happen? So you can always mouse over and do that sort of stuff. So like, one of the best practices right now is to use the time element in HTML. So you do something like this. Browsers that don't understand the time element, which is pretty much all of them at this point, understand it. They'll just print out 6 minutes ago, and that's cool. The time element's kind of interesting because you can add a title to it like GitHub was doing and print out like an actual human readable format and say like, oh yeah, now we know it's January 24th. Cool. And that's helpful. But you can also add like a date time attribute to the element as well. And this is obviously printed out in 8601, because it's everywhere. And this is a nice way if you're trying to support people building tools on top of your site, if they want to spider something and try and figure out like, how do I convert this weird-ass relative time to something I can actually use? All this stuff is a lot easier, and again, if you can abstract this out and print all of your times this way, it just makes everybody much better off. Next little sort of thing is inputting time into your website. I don't know if you've noticed this, but every single date input and stuff is pretty much the worst thing I've ever used. I don't think that there's a super good example of this, and it really bothers me. So we'll probably make our own at some point, and I'll be equally as bad in other ways. This is kind of the segment in the talk where I just say everything is really terrible. Step one, input. Input is interesting. It's also terrible in a lot of ways. Some browser people got together and they're like, wow, yeah, everybody has their own date picker and stuff. Wouldn't it be cool if we just standardize all this madness in like the input element, because everybody uses the input element. So you have stuff like input type equals time. And that's kind of interesting, and you can have like a time selector and stuff like that. And then you have input type equals date. And it looks kind of terrible, but like this is Chrome, for example, and it's useful, and you don't want to have to like build all this stuff out for yourself. If you do like an input type equals date in Safari, for example, you don't have the best experience of your life. Degrades gracefully, sort of, but I guess it's like completely up to the user as to like how they actually want to do all this sort of stuff. So yeah, that's terrible. Input is not super well supported. And like you can't really restyle input, so you're kind of stuck with like what the browser has suggested for you as like exactly how you want to display this in your browser and stuff like that. So you can't really restyle it comprehensively. I have somebody who knows input very well, knows all the ins and outs and stuff, and I was like, when will input equals date be well supported? And she said, oh god, probably never. So yeah, everything is terrible. The best advice I have here is, I guess, just pick something, try to style it really well, and then give up, and just move on to something else, because you can spend so much time doing like the perfect date picker, time picker, whatever picker, and it's going to be terrible. Yeah, everything is terrible. That's my talk. Time logic, next little thing. There's a lot to talk about the actual time, like the logic with like how do you use time in your app and software and stuff. Natural language is really hip in 2009. I guess it's getting hip again or something, but you can get like really complicated details and all that sort of stuff, or you can do kind of very simple stuff, like a third Wednesday in November at 3 p.m. We have the technology to do this. The product gem is the best way to do this in Ruby. It's been around for like years and years and years now. It's well tested. It's like the easiest way to parse out the sort of natural language writing in Ruby to something you can actually use on your backend. Next little thing is recurring events, and I'm just going to stop you right here. Like everything is truly terrible, and it's really the worst. Like as much as possible, try never to have to deal with recurring events. It's terrible, because if you look at something like every Tuesday at 2 p.m., that seems so nice and easy. And then obviously if you start modeling this in a database, you say, okay, I'm going to insert like a time for everything. And obviously, like after a while, you're like, oh wow, that goes to infinity, and then goes backwards to infinity. Like, does Amazon have a database that stores infinity yet? I don't know. So it's unlikely you'll probably want to do this. You probably want to put a hard boundary on first the start and the end of any recurring event. There are ways around this. So you end up using kind of like a shorthand notation, something like this, for example. And Martin Fowler wrote like a really accessible white paper if you want to read this sort of stuff, where he calls them temporal expressions. He kind of like breaks down a way of like modeling a recurring event in your software. Totally worth a read if you're a nerd like me. And we have a standard, again, RFC 5545, which defines these recurrence rules, they call them. And there's a lot of really complicated problems even on top of this. Because even like the simple, like every Tuesday at 2 p.m., you start asking yourself questions like, well, what about daylight savings time? Does it stay 2 p.m.? Does it change with that? What if there are other people who don't follow daylight savings time at the same time? How about every Tuesday except what if the user doesn't want to do March 13th and March 20th, which is then moved to the 21st at 3 p.m. All of this is terrible. Like, I don't know how to say this. Our rule, none of the standards actually describe like how you pronounce something, which is really bothersome to me. But they handle all of this sort of stuff. It's just really, really complicated. X dates, X rules, until, tens, counts, all this sort of stuff. It would take a long talk to talk about all this sort of stuff. In Ruby, if you're stuck doing a lot of this sort of stuff, IceCube is a really good gem to kind of tackle this. They kind of break up the temporal expressions into something that is a Ruby object, and you can start iterating over stuff in the back in that way. But all this stuff is just really, really complicated. And as much as possible, like I try to say, like try to use real records. So if you can get away with, if you're building some sort of scheduling application, and you can get away with saying, yeah, every Tuesday at 2 p.m., but you only run it for like a year, in your database, and you can just build out those objects directly. It's so much easier than trying to have to calculate this for every page view or cache it or whatever the case is. So place boundaries as much as possible on these things if you can. So that's a lot of what I want to talk about today. Kind of in like the last little bits is like, oh my god, I've been working for like a year or so building this calendar out, and it's been terrible in a lot of ways, but also interesting. And if I had some like advice kind of stemming from all that stuff, like one, use standards where possible. I don't know if you noticed this, but I really like ISO 8601. It's a good ISO standard or something. This only matters if your software has to talk to other software, which is probably all of them. But it also means like use time libraries as much as possible as well, because lots of people are much better at this than you are, probably. So use their brains and use like somebody else's library that handles all these edge cases for you. Simple and efficient is usually the best, which is weird to say. Like computers are all like efficiency is the best and everything. Now when it comes to time like adds up. Like all these edge cases get really, really complex. So if you can just be really stupid and inefficient if you can, usually that ends up being the best because we're not doing like nuclear reactor silo programming in Ruby. Right? I don't know. If somebody was, that'd be awesome. And I'd be terrified. I'm trying to figure out where that reactor is. But yeah, try to use like the simplest thing. It's kind of standard software thing. Like try not to overthink things. Go as simple as possible. And that's probably good enough for what we're trying to do. The other weird thing that I've kind of stemmed in, kind of figured out over time is we try to handle more of our logic in the client. So we treat our server, the way we have stuff set up is like we have a JavaScript front end, Ruby and Go back end. So we treat like our server side stuff as simple as possible. It doesn't know anything about time zones, it doesn't know anything about like daylight savings time, no sub-recurring event stuff, but not a whole bunch. And we try to unravel a lot of that stuff on the client side, which is kind of backwards compared to a lot of other things. But we found it to be a lot easier just to have like a very standard, simplified backend that's the interface to everything else you're going to end up using. Otherwise, it gets really complicated really quickly. So that's mostly what I have. Hopefully I convinced you never to build a calendar. I don't need the competition. But hopefully I think, hope you think that like time programming isn't quite as scary. Like all the time stuff is really weird because people have written down something in a spec somewhere, so like there are answers to everything. But if you can just avoid doing it as much as possible and trying to do these simple things first, that's usually a better way. So with that, I think my time is up.